What's going on, 7th grade? Welcome to our study guide video. Let's get ready for our test coming up. Let's get started. So, first off, we got our Zard right here. You already know. Come on now. So, it wants to know which graphs cannot represent a proportional relationship. Select all that apply. So, it wants to know which ones cannot. So, it wants to know the ones that are not proportional. Well, here we can see that if I was to connect these dots here to make a line, because that's what a graph is, we see that that line is straight, and we see that that line goes through the origin. So that means this line is proportional. I should say this graph is proportional. And then finally here, we can see we do have a straight line, right? So this is a straight line, but it doesn't go through the origin. So that means that this is not a proportional graph. And so we could circle this one. Finally, we go here to part C. What we can see here is that part C doesn't go through the origin and it's curved. So this is curved. So it's not straight and it doesn't go through the origin. So that means this is not proportional. And then finally, for part D, this is a straight line and it goes through an origin. So that tells us a proportional line is a line that is straight and goes through the origin. If you understand this part here, that your line needs to be straight and go through the origin, you're going to be all set. And again, if you don't remember the origin is located here. The origin is the starting point of the graph, also known as 0, 0. So it has to go through the origin and it needs to be straight. Here's one option, and then here's another one where we had to draw the line, and we can see it also goes through the origin. And notice here that this one did not go the origin, and let's keep going. All right, so let's go through this problem here. First off, I am going to teach you how to cheat on this test, aka how to use your test taking strategies. Look at this. We got my boy Zapdos with his buddies. We got the homie Articuno and Motrez here. Let's go. All right, so a grocery store sells sliced turkey. The graph shows a relationship between the weight of the sliced turkey and the total cost of the sliced turkey. 2 points, R and W, are labeled on the graph shown below. And so here we have the cost of turkey, of sliced turkey. And so R means the unit rate of $10 per pound. And so here's point R, and then we have point W. Here we have our dependent variable Y and our independent variable X. And so what we have here is 4, 10. So it says point R means the unit rate is $10 per pound. Well, we can see here, right? And this is how you label these points, right? This is $10, right? Because 10 is located here. So this is Y, that is X. So $10, right? Total cost for 4 pounds. So that means 4 pounds cost $10. We can cross this one right out. Look how we're using the possible answers and then seeing, can we prove that with our graph? Point R means that the unit rate is 4 pounds per $1. Well, what we can see here is that 4 pounds actually costs $10. So it's not $4, it's not 4 pounds per dollar. And so that leaves us with point W as one of our possible answers. Point W means that the unit rate is $2.50 per pound. Well, let's see if that's right. Here we have pounds. Here we have point W. We see that 1 pound costs some amount. we see that this is $2.50. This is right up here. And so we know that $2.50 is our y, 1 is our x. So this is saying that $2.50 per 1 pound. And so that means this one is our answer. And so you are going to get one on the test that has your, it will say this, point W means the unit rate is 2.5 pounds or 2 and 5 pounds. Oh, I can't speak. 2 and 5/10 pounds per dollar. This is to throw you off because it's not 2.5 pounds. What we can see here is that it's 1 pound to $2.50. And so that means it's $2.50 per pound. And if you read up top and understand that you're looking at the cost of like deli turkey, it would make more sense to do $2.50 per pound. Let's move on to the next one. All right, we got my boy Alakazam to help us with this problem. So here we have at the grocery store, you can buy 3 pounds of cherries for $7.50. The relationship between the amount of cherries in pounds, P, and the cost of cherries, C, is proportional. Which equation can be used to represent this relationship? And so first question is, right, our constant proportionality is K is equal to our dependent variable divided by our independent variable. So what's our dependent variable? If we remember that our equation is our dependent variable is equal to our constant of proportionality times our independent variable, we can cheat on this question. Meaning, right, if I look here, I know that C needs to be my dependent variable. So that means the cost of cherries is my dependent variable. So that means my dependent variable is $7.50. And so that's $7.50, which means my independent variable is P, which is 3 pounds, right? 3 pounds of cherries. And so that's 3 pounds. And so I know that my constant of proportionality is going to be $7.50 divided by 3. And so let's look at our possible answers here. First off, I know 9 divided by 3 is 3. So right off the bat, I can take this second one off the table. I know it's not that one. Second off, this $7.50 would be the price of 3 pounds, not 1. So I know here I can cross this off because $7.50 divided by 3 is not $7.50. And so that leaves us in between $2.50 and $4.50. And so I can just do this division out. So we get $7.50 divided by 3. 3 goes into 7 2 times. So I subtract. 7 minus 6 is 1. I carry up my decimal, bring down my 5. 3 goes into 15 5 times. 5 times 3 is 15. 15 minus 15 is 0. I carry down my last 0. 3 goes into those zeros 0 times. And so we end up getting $2.50. So that means my equation is C, because that's my dependent variable. I substitute my constant of proportionality with $2.50 times my independent variable, which my independent variable is P. And so that leaves us with C is equal to 250 times P. Now, I could have crossed this one out because I know 4 times 2 is 8. And so you could have already estimated that $4.50 is not $7.50 divided by 3. So this is a problem you can cheat on because you don't actually have to do any math if you have this background knowledge already, right? You can cross off here because you know that 750 divided by 3 is not 3, right? Because you know 9 divided by 3 is 3. Second one you can knock off is here because 750 divided by 3 is not 750. And then you could have estimated the fact that 750 divided by 3 is not 450 because 4 times 2 is 8, and 8 is bigger than 750. And so there is a way you could have cheated on this question without actually doing any math. You're like, Mr. Mill, why you're telling me how to cheat? It's because I want you to be able to do that on MCAS. I want you to be able to do that on MAP, because if you can do it on MAP, you can do it on MCAS, you can do it on the SAT, and if you can do it on the SAT, it makes college cheaper. All right, we got the Pikachus helping us out on this problem, right? This is measuring two measurements, so we got two chews here, you already know. So here we have meteoroid, Pestroid 245, and asteroid X traveled through the solar system. The graph shows the distance each traveled after a given point in time. Is asteroid X traveling faster or slower than Perseid 245? Explain how you know. Well, looking at this graph, we know we have our distance as our dependent variable and time as our independent variable. And so time can be represented as t. And so if I was to pick a point here at any point, right? So whenever I start from my independent variable and I hit this line, I can go to the side here. And this is where like we get some distance. So let's say it was maybe 10 seconds. It traveled, 300 meters or something like that. And so I keep on going up now, and I can get to asteroid X and see that I connected in 10 seconds here, right? And maybe this is higher, right? So maybe this is 600, because as we go up, it gets more. And so what we can see is that with the same amount of time, asteroid X traveled further, right? And we can see this because our line is accelerating faster, right? So this line here is accelerating faster than Pestroid 245. And so without even looking at these points, we can see that asteroid X is traveling faster because it is traveling a further distance quicker. No matter where you check, Pestroid is always going to be traveling at a faster rate. Asteroid X. So we would say asteroid X is traveling faster than Perseid 245. How do you know this? I know this because the line for asteroid X accelerates faster than Perseid 245. And with this reasoning in conjunction with the work that we put on this graph, that is how you would answer this question. And so when you're looking at linear lines, the linear line that is approaching, like the linear line that is closest to being a vertical line is the line that is traveling the fastest. So we can see here that this separation that we see, right? That separation is because asteroid X is traveling faster than Perseid 245, right? This is never going to catch up to asteroid X, and asteroid X is going to continue to separate as it continues. So let's go to the next one. All right, so here we have the question. A recipe says that 6 spring rolls will serve 3 people. Complete the table. And so what we understand is that in a proportional table, each row is going to have the same constant of proportionality. Throughout this whole test, throughout this whole study guide, we always need to remember that in order to find our constant of proportionality, it's a ratio between our dependent variable and our independent variable. So I know that this side is my dependent variable, and here is my independent variable. And so I can extend our table and find our constant of proportionality, which is going to be the number of people over the spring rolls, because it's our our dependent variable over our independent variable. So here I have 3 divided by 6, which when we solve that is reduced down to be 1/2, also known as 0 and 5/10. And so what we remember from our unit 1 in scaling is when we go from the left to the right, we multiply. So I apply my constant proportionality by multiplying 30 by 0 and 5/10. Well, what's half of 30? 15. And so now I go here. So here we have 40 going to our dependent variable. So again, we multiply again. What's half of 40? Well, half of 40 is 20. And so here we have 20. And now we go from the right to the left. And so here, instead of multiplying, I can divide. So I'll divide by 1/2. And so just for funsies, we can do 28 divided by 1/2, right? And we know when we divide by a fraction, we need to take the multiplicative inverse. And so we use our strategy of keep, change, flip. And so we keep 28, we change from division to multiplication, and then we take the reciprocal of 1/2. And the reciprocal just means we flip it, so times 2. That kind of looks like a heart. And so 28 times 2 is just 46. And so that means the number of spring rolls, 46, feeds 28. And that is how we complete the table. And for funsies, you can say that the number of people depends on the fact that, right, half a spring roll, right? So bam, that could be our equation. So again, this is how you apply your table. This is all you have to do on this question on the test. I'm really excited to see how you guys do. Y'all just need to remember is you always need to find your constant of proportionality, which is your dependent variable divided by your independent variable. Let's move on to our next question. So you're going to get a question on your test that says, is this equation proportional? Explain or show your reasoning. How you're going to explain your reasoning is by mentioning the following. So a proportional equation always looks like our dependent variable is equal to our constant of proportionality times our independent variable. An example of this is y is equal to our constant of proportionality times x. And so let's say our constant proportionality in this case is 2. A proportional equation could be y equals 2 times x. Here, this side is proportional, but what makes it not proportional, so an example that's not proportional, would be y is equal to 2x plus 4. And so if you ever see anything that's being added on or subtracted on, it means that that's not a proportional equation. So what we can see here is that here select all the equations that you think are proportional. And so here we're adding on, right? Not that part, but we're adding on this 4. That means that's not proportional. We'll come back to this one. Here we have 4 to the power of x. That's an exponent. Exponents are not proportional. Here we have y is equal to x to the power of 4. Again, this is an exponent. Exponents aren't proportional. Here we have y is equal to 4 times x, right? We have our dependent variable is equal to k times our independent variable. This one is proportional. So let's talk about this one. Dividing by 4 is the same as what? If you said dividing by 4 is the same as multiplying by 1/4, you'd be correct. And so because we're doing y is equal to k times x, this one is also proportional. And we can show that through these tables. So if x is 2, so an example, this would be y is equal to 4. plus 2, that would be 6, right? 3, 4 plus 3 is equal to 7. 4, right? 4 plus 4 is equal to 8. 5, 5 plus 4 is equal to 9. 6 divided by 2, right? Our constant of proportionality here. Okay, right? Y divided by x. 6 divided by 2 is 3. 7 divided by 3 is actually 2.3 repeating. These are not the same. What that means is that this one's not proportional. Y is equal to 4 times x. Well, I can do y is equal to 4 times 2, right? When x is 2, that's 8. 3 substitutes x. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Throughout this whole table, our constant of proportionality is going to be 4. And because each row is an equivalent ratio, I know that this table is proportional. And so, just skipping down here now, what do equations of proportional relationships have in common? They all have a dependent variable is equal to constant of proportionality times an independent variable with no exponents or something added on. And so that's important for this problem. Let's get on to our last one. All right, now to our last question. Scott delivers a leak in his kitchen sink. He puts a bowl under the leak to collect water. The graph below shows the relationship between the number of hours water has leaked and the amount of water in cups collected in the bowl. So here we have in our dependent variable, right? Our dependent variable is water in cups, so we can call that C. And our independent variable is hours, so we can say hours is going to be H. And so we're measuring how much cups of water is collected within some amount of hours. And so here it wants to know, what does the point 5, 2 and 5/10 represent in this situation? What we need to remember are that points are always written as our independent variable, our dependent variable. So in this case, in this problem, our independent variable is hours. So we would write this point as hours, our dependent variable, which would be C. And so here we have 5 hours. We collect 2 and 5/10 cups. And we can see here in 5 hours, we collect 2 and 5/10 cups. So here we have the point 5, 2 and 5/10. And so we would say we collect 2 and 5/10 cups in 5 hours. And that's how you explain this point. Going on to part B, what is the rate in cups per hour at which the water is leaking? So this is asking for our constant of proportionality, which is just 2 and 5/10 divided by 5, which when we do this out, we end up getting 0 and 5/10. So we would say we collect 1/2 cups per hour. And so now it wants to write an equation where we have C, the number of cups collected for the leaking sink after H hours. And so our dependent variable is equal to C. Our independent variable is equal to H. Our constant of proportionality that we found up here, right, which is our cups per hour, was equal to 0 and 5/10. What we remember throughout this whole study guide, throughout all our units, our equation is our dependent variable is equal to our constant proportionality times our independent variable. So here our dependent variable was the number of cups. That is equal to our constant of proportionality, which is the only variable we substitute with our number, right? That is 0 and 5/10 times our independent variable, which is the number of hours. And that's our equation. And now for part D, the bowl that Scotty put in the sink to collect water can hold 32 cups. After how many hours will the bowl be full of water? So here we have C is equal to 32. Our equation is up here, so C is equal to 0 and 5/10 times H. And so what I can do is I can substitute 32 in for C. So this becomes 32 is equal to 0 and 5/10 times H. And so now this is a throwback to 6th grade where we have a one-step equation. I can solve for H by dividing 0 and 5/10 from both sides. And so I'm left with H is equal to 32 divided by 1/2, which maybe I can do that on the side for funsies, right? 0 and 5/10 as a fraction is 1/2. So I can do the multiplicative inverse here. I keep my 32. I change from division to multiplication. And then I take the reciprocal of 1/2, which is 2. 32 times 2 is 64. And so we end up getting 64 hours. And again, you guys will have a calculator for this one, but I did want to show you just how to do it without one. And so here we would say we collect 32 cups in 64 hours. And that was our final study guide question. You guys are going to rock it tomorrow. Well, not tomorrow, but when we have our test. Let's get it.